Hi, today we are here to see about data structures. What are data structures? Why do we need to learn them? And how much it's important to the computational logic. Data is said to be a collection of facts. It could be a number, it could be a word, it could be a measurement, observations, or description of things. Like you could say it could be an age, right? It could be a qualitative or a quantitative. Yeah. So if it's qualitative, then you could say it's so descriptive. Okay. You could say it's good, it's bad, it's great. That's qualitative. And if the data is quantitative, it represents numerical information like age, height, weight, money. These are some examples of qualitative and quantitative data. It was great fun, which describes something, so it's descriptive. Quantitative, which is discrete or continuous. Okay. Discrete in the sense it could be exact values like 5 or 10. When you say continuous, it varies continuously. It could be a range of values. What is a structure basically? The arrangement and the relation between the parts of elements of something complex, something which is arranged according to a plan or a pattern, is said to be an organization or a structure. The veins of a leaf have a pattern. The DNA structure of human body has a pattern. The puzzles of the kids play have a pattern. The building has a pattern of different structures. Patterns are so important. Similarly, a data also needs a pattern or a structure. Why? Just because we want to store them in that format so that the efficiency of accessing them and modifying them becomes more flexible. You automated a to-do list? Then we need to arrange the data in a format of a list. You need a stacking of data like messaging apps where you need to look into the recently updated message first. So then you go for a stack kind of an organization. You need a queue of data where you have a queue of callers calling into a call center, and you need to allocate them into a queue and then service them according to their time of entering the queue. You want to maintain a tree kind of a structure where you want to maintain your family hierarchy, the data about a family. Then you go for a tree data structure. You want to have a network kind of a data, then go for a graph data structure. You need a graphical implementation of the data. You need the digital road. See this example of a digital road network where all the distances are defined by the lines, or we call it as edges, and the nodes, the points, or the nodal regions that are supposed to be connected. This is a basic representation of a graph data structure. So this is how the points there 0, 1, 2, and 3 and 4 represents nodes or vertices, and the lines that connect them are called edges if they have a path between them. So basically data structure is made up of two kinds of structures, primitive and non-primitive, which is in which non-primitive is categorized into linear and non-linear, and basically the trees, stacks, linked list, arrays, queues, and graph, among which trees and graph are non-linear, whereas the others are linear. Thank you.